Impact testing of materials. Detailed explanations of Charpy and Izod impact tests. What is impact testing? Impact testing is a dynamic mechanical test used to determine the ability of a material to resist fracture under sudden shock loading. Unlike tensile or compression tests, which applies load slowly, the impact test applies load very rapidly. It mainly measures the impact strength or toughness, the amount of energy absorbed by the material before fracture under high strain rate loading. It measures the energy absorbed by a material during fracture. It is mainly used to evaluate toughness and notch sensitivity. They are classified as Charpy and Izod impact tests. These tests are also called as notched bar impact tests. Principle of impact testing. A standard notch specimen is struck by a swinging pendulum hammer. The specimen fractures due to sudden high strain rate loading. The loss in the pendulum energy before and after fracture gives the absorbed energy. Impact testing machine. What are all the components of the impact testing machine? An impact testing machine consists of a pendulum hammer through which it strikes the specimen, and a pendulum release lever which operates the pendulum hammer, and a calibrator scale which consists of both Izod and Charpy scale, and a pendulum brake which is used to stop the pendulum after the impact, and a specimen holder to hold both the specimens. So this could be the experimental setup of the impact testing. It indicates the starting position and end of the swing. It also consists of a scale, an anvil and a specimen. On coming to Charpy impact test. Charpy V-notch impact test is a relatively simple test that utilizes a relatively cheap small test specimen. Tests can readily be carried out over a range of subambient temperature, which is lower temperatures. It is said that the test can also be carried out in a very lower temperature. The test is used for comparing the influence of alloy studies and heat treatment on notch toughness. It frequently is used for quality control and material acceptance purposes. Dimensions of Charpy specimen. The length of the specimen is about 55 mm and the cross section area is 10 cross 10 mm and the V notch angle is 45 degree and the notch depth is up to 2 mm and the root radius is 0.25 mm. The specimen is placed horizontally and supported at both ends by the specimen holder. So we could able to see the notch depth of the V notch specimen is of 2 mm and the U notch is up to 5 mm. On seeing the image, we could able to observe that the specimen before impact test and the specimen after impact tests. So this could be the visual representation of the specimen. We could able to see the test sample is held at the specimen holder and the hammer is made to impact on the test specimen. On coming to Izod impact test. The Izod impact test is a standard impact testing method used to determine the impact strength or toughness of a material. It measures the energy absorbed by a material during fracture when subjected to a sudden blow by a pendulum hammer. This test is used to evaluate the resistance of a material to sudden impact loading. Dimensions of Izod specimen. The Izod specimen is of 75 mm in length and the cross section area is up to 10 cross 10 mm and the V notch angle is 45 degree. The notch depth is up to 2 mm. The specimen is clamped vertically with notch facing the striker. We could able to observe the notch in the specimen and the notch depth is up to 2 mm and the notch degree is 45 degree. So on the below image we could able to observe the Izod impact testing material. So this could be the visual representation of a Izod impact testing. So the specimen is placed vertically facing the notch to the pendulum, in which the on impact we could able to measure the impact strength. To calculate the impact strength, we could able to get through it by energy consumed by area below the notch, which is further could be told as impact test equal to E2 minus E1 divided by B into D, which is breadth into depth, and which is also denoted by a unit joules per millimeter square. The properties of the materials determined are impact strength. The impact strength is the amount of energy absorbed per unit cross sectional area before fracture under impact loading. It indicates the ability of a material to withstand sudden shock without failure. Higher impact strength means better resistance to brittle fracture. For example, a car's bumper is made up of a tough polymer which could resist sudden impact. On coming to property 2, it denotes the notch toughness. The notch toughness is the ability of a material to resist fracture in the presence of a stress concentration notch. It evaluates sensitivity of materials to flaws, cracks, and discontinuities. Materials with high notch and toughness are safer for structural applications such as buildings and bridges. Ductile to brittle transition temperature, which is also known as DBTT. DBTT is the temperature at which a material changes behavior from ductile to brittle. Below DBTT, sudden brittle fracture occurs, but above DBTT, material absorbs more energy and shows ductile fracture. It is very important for low temperature applications. On coming to the property 4, fracture characteristics. Impact test helps analyze fracture surface appearance, whether it is a ductile fracture or a brittle fracture. We could able to observe the types of fractures by its appearance. Ductile fracture shows fibrous, rough surface and higher energy absorption appearance, and the brittle fracture shows smooth, shiny cleavage surface and low energy absorptions, in which helps us to identify whether it is a ductile or brittle behavior of fracture. On coming to the applications of impact testing, the first is structural steel selection, used to ensure safety in bridges, buildings, and towers, which could also be told as the construction of bridges and the buildings. Pressure vessels and boilers, to prevent catastrophic brittle fracture under sudden loads, such as boiler steel plates, etc. Shipbuilding and marine structures ensures materials can withstand cold sea temperature. Ability of a material to withstand a lower temperature, such as oil tankers, and railway components and automotive parts used for axles, gears, shaft subjected to dynamic loading, which could also be told as a railway axles, which could resist dynamic loading. Cryogenic applications determines the suitability of materials used in LNG tanks and low temperature storage. On seeing quality control, it is used in industries to verify batch consistency and heat treatment quality. Advantages of impact testing. Simple and quick method. Provides rapid evaluation of material toughness. It is a simple and compact method to be carried out to determine a material's impact strength. Economical testing procedure. Requires small specimen and less preparation. The apparatus is of simple construction and it requires only a small piece of specimen for the testing. Evaluates real service conditions. Simulates sudden shock loading experience in practical application. We could able to observe the sudden shock or impact test on the specimen. Useful for temperature studies, which is helpful in the determination of DBTT and suitability for cold environments. As we saw earlier, it is also be carried out in a subambient temperature, which is also known as lower temperatures. Detects the material's defect, sensitive to internal flaws and microstructural changes. We could detect the internal cracks or the micro cracks of the material through this test, which we could able to measure the impact strength. Assets in material selection helps engineers choose safer and tougher materials. On testing various materials, we could able to observe what are all the applications and properties of each of the materials. For the required applications, we could able to select the required specimens. Thank you.